I'm going to share my screen. I'm going to go through just a couple of norms. So this session, if you've been joining us for the other sessions throughout the day, this one will look a little bit different. This is your time to be in the spotlight, and I'm really excited to get to be the host of this. If you haven't met me yet, my name's Teresa Gibson, and I will be hosting the 2 minutes with a mic sessions. I've been working all day with the speakers, and I'm so excited. This is absolutely the reason that we are here today. I cannot wait to hear about your research. So as we go through this, I just want to give you a little bit about how this will work. The session's going to be a little different, and so I'm going to just set a couple of norms for researcher courtesy. You will have full driving control in this session, which means you should be able to mute and unmute and also share your screen. And so just as we get started, I wanted to make note that we would appreciate if you could stay on mute unless recorded. You can absolutely do that cheering in the chat, ask great questions, etc. But because the researchers only have 2 minutes, we want to give them that time with the microphone. So we appreciate your participation. We're also going to ask that you respect the timer. And so it's a little wonky because you're sharing your screen. I can't display my timer. And what I will do is at 30 seconds, I will just give you a heads up that you have 30 seconds left. And so I apologize if I will be interrupting you. I'm going to apologize in advance because I want you to have the ability to share your screen. With that said, you are not required to share your screen. I do want you to ask great questions and to cheer each other on in the chat. And so feel free to jump in there, keep the chat going, ask each other questions. If someone has presented and you have questions for them after they go, drop those in the chat, and you are welcome to answer each other. So you are answering your peers in that chat section too. And finally, make sure you ask some good questions. This is all about new ideas, new thinking. And so as people present their research, one of the best things we can do is ask them the questions we're wondering about to help them wonder about their next questions that they will do research on. How will it work? I am right now sharing my screen. And so I, as the host, my primary role will be just to pull up the next slide. The slide will have your project name and your name on it. And that will be the transition time that allows one speaker to mute their mic and stop sharing their screen while the other speaker that is coming up has a chance to start sharing their screen. So if you noticed in the schedule, I gave you a little bit of transition time. I don't want you to feel rushed, and I want you to get your 2 minutes. So each time I will pull up the slide for the next project. And with that, that will be the time where you are able to get your technology together, start sharing your screen, and one group, the prior group, will mute, and the new group will jump off of or onto the microphone. And that is how we will pass the mic today. And so before I start with our first project, I just want to make sure if you have any questions, you can jump on the mic or drop them in the chat, and I can get us rolling. And my chat went away, so I better pull it up to make sure that if you have questions, I can answer them. All right, so what we will do, there have been a couple changes to the judging schedule, so I'm not sure if we'll hit conflicts, but I do want you, if you signed up, I definitely want to make sure you get your 2 minutes. So if a student gets pulled out for judging, I will pull their slide back up at the end to see if they have been able to join us from their judging session and still want to present. So you can help me out a little bit with that. And while I pull up my timer on my phone, I will also pull up our first project. So this is not the first project. There we go. Machine learning for predicting diabetes among humans. And with that, I'm gonna give me 1 second to pull up my timer so that I am ready. I do have a timer. Where is it? There it is. All right. And I am all set. I will not start the timer until you are all ready to go. So I will mute now, and is our first
Hi, my name is Srija Roy, and the title of my project is Machine Learning to Predict Diabetes Among Humans. The goal of my project is to use an artificial neural network model to predict diabetes. And in order to do this, I used the early stage diabetes risk prediction dataset obtained from the UCI machine learning repository. This dataset had a sample size of 520 observations and includes information about each observation, such as age, gender, and previous medical health conditions. The artificial neural network model mimics how the human brain functions. The reason I chose this model is because it has been successfully applied to find patterns in complex datasets. First, I used the train test split function from the scikit-learn library of the Python programming language to divide the dataset into training data and test data. Training data was used to train the model, and test data was used to evaluate the model's accuracy. I experimented with different train test splits, and overall, I found that most accuracy scores were above 90%. In particular, when 20% of the model was used as test data and there were 2 hidden layers, which is another important parameter, the artificial neural network model gave me an accuracy score of more than 98%. In conclusion, my model did a good job predicting patients with diabetes, and I've created a demo web application using this model, and with additional data, I believe this web app model could be deployed in a medical work environment. Thank you.
Excellent. Thank you so much. And you did it in a minute and a half. So excellent timing too. Very well rehearsed. All right. And with that, we're going to move to our next project. So I will grab the screen and pull up our next researcher. So our next project is mechanical magnetism to boil water. And hopefully we have had a little bit of time to pass the mic. And so Alexandra, if you want to jump on, let me know you're here.
I'm right here.
Wonderful. All right. I will mute myself and give you a second to get rolling, and then I will start the timer. Welcome.
All right, I'm ready. So my name is Alexandra Scarlett, and my project was about boiling water using magnetism. And how it works is the motion of the magnetic field lines interact with the electrons and the atoms of the copper that I used to heat it up to transfer energy. And this allowed the copper pipe to heat up. In order for the pipe to actually heat up, you needed magnets that would alternate north and south so that the electrons and the atoms of the copper would vibrate and heat up. And I recorded the temperature in about 30-second intervals using a digital infrared thermometer. And it got up to 275 degrees, which is more than enough energy to actually boil water, meaning that we can use magnets to boil water. And I thought about doing this project because we do use rotating magnets for stuff like electricity, but I haven't seen anything for water. And that's something that we use a lot every day, use water for almost everything we do. And I wanted to create something that was more environmentally friendly and that would create possibly less pollution. I did this experiment for about 4 minutes and I got to 275 degrees, which means you could boil water in about 4 minutes using this project. One of the hardest things was getting the speed right and being able to put the magnets together to get the project moving. And that's about it. Thank you.
Great, wonderful. Thank you so much. All right, our next researchers, our next project is black on white, the best color combination for media. And so I would ask the PES team to mute, and then I'm going to pass the microphone over to Ananth. And you can let me know when you are ready.
I'm ready.
Wonderful. I can start your timer. Go right ahead.
So my project explored whether black on white was the best option for media. Right now on most media prints, the text is black on white, but is that really the best color to use? The purpose of this in the real world is when driving or even reading text messages, generally the font is black on white. And when authors write a book, they write it so that people will read it and enjoy it. Sometimes authors add pictures to captivate readers, but maybe they should change the font color. So to do this project, I first selected an alternate color contrast, and according to my research, a every single color is best seen at 555 nanometers. So I had to choose one color that at 555 nanometers with an alternate background. So I did a little bit more research and realized that the greater the color contrast, the better the human eye perceives it. So I ended up deciding on green on black. Afterwards, I made a card consisting of 40 words, 20 black on white words, and 20 green on black words. I distributed these cards to all participants and asked them to try and remember as many words as they could in 1 minute. We then gave them a minute to write down all the words they remembered, and then afterwards I would look at the card and match the word that they wrote down to what the color was on the card. And generally,
30 seconds.
More participants retained more green on black words. I'm done.
Wonderful. Thank you so much. All right. And with that, we will pass the microphone. And so let me pull up our next project. All right. So our next team, oh, this is actually a team. I keep saying team. Our next team of researchers are going to talk to us about Daphnia water quality detectors. I'm interested because I don't know what that means. Are you all ready? You can jump on the mic and let me know.
Yep.
Wonderful.
Hello, I am Rishi Soraya.
And I'm Kavya Diliban. Did you know that switching to Daphnia could save you $60 or more in 1 hour while saving lives?
The goal of this project was to identify a feasible solution to detect the quality of water. We started with the question, how effective is using Daphnia to detect the runoff water quality from a street, stream, and construction site? Next, we researched about Daphnia, which is shown in quadrant 1.
What are Daphnia magna?
Daphnia and magna are the common water fleet are positive bioindicators, which allows them to determine the quality of water. The location of runoff water affects pollutants because only certain pollutants can affect your general area. Unlike Daphnia, traditional water quality detectors cannot test for every pollutant and are expensive, but Daphnia, on the other hand, cannot tell the exact amount of specific pollutants, so it can be used as a preliminary tester. This led us to believe that if Daphnia are added to raw runoff water, then more of the Daphnia would die because it has stronger pollutants. If the location of the runoff is near the street, most of the Daphnia would die because it has the most pollutants.
In our experiment, we put raw and diluted runoff water samples and we put Daphnia in raw and diluted runoff water samples and counted how many Daphnia died in each trial after 1 hour. Our results show that our first hypothesis was supported. More Daphnia died in the raw runoff water than the diluted samples. On the other hand, our results do not support our second hypothesis. The construction runoff water killed the
30
most
seconds.
Daphnia than oxidized iron. Overall, Daphnia are effective at determining water quality as a preliminary detector. Because Daphnia are difficult to count, in the future we can use a different bioindicator to make it more accessible to people because it's hard to count. In the real world, we can use Daphnia water quality detectors to assist impoverished communities with water testing and help monitor the water quality. And that's all. Thank you for listening.
Wonderful. Thank you. That was great timing. All right. With that, I will ask you all to mute and I will pass the microphone. And so our next research project is It's a Toss-Up. And so if you want to jump on the microphone, let me know when you are ready. Is our researcher with us? Let me just double check, make sure. Oh, I see you on the phone. Laylee, are you actually there? I don't want to miss you. All right, maybe she can resolve that. We'll pull her back up in a little bit and we'll move on.
Okay, can you all hear me?
Yes, we can. Wonderful.
Okay, sorry about that.
No worries at all. All right, so
Okay.
Go right ahead. You tell me when you're ready.
Okay, yes, ma'am. I am ready. I'll be
All right.
starting. So hello, everyone. My name is Lolly Beth Weymouth, and I'm in attendance today representing the French Broad River Academy for Girls. I'm in 7th grade, and the projects from our school here today were from our annual 7th grade science fair every year. So I decided to brace my project, it's a toss-up, upon physics, mathematics, and football because those topics are very important to me and to my family. I enjoy watching football with my dad and my grandfather, and I love to do interesting math problems and problems involving physics in the real world. Therefore, for my experiment, I wanted to test the question of, does the angle of a football launched affect its distance traveled? So for this experiment, I initially predicted that the higher the angle thrown or launched, the farther the ball would go, but this was proved wrong with my experimental results. I initially thought that if we released the ball at a higher angle, an angle above 50 degrees, that it would travel farther as opposed to releasing the ball at a 30-degree angle, believing that it would travel a shorter distance. I was able to test my hypothesis by measuring the angle of a football launched using a football launcher, a protractor, and measuring how far each ball traveled in yards. I then found out that the optimal angle to launch the ball at was around 43 degrees, not supporting my initial prediction. And I found that the ball released at the highest angle, 64 degrees, traveled at around an average of 15 yards, whereas the angle at which the ball traveled the farthest, around 35 degrees, was at an average of around 21 yards.
30
and
seconds.
again, the optimal angle was at around 43 degrees. And then I hope that you all have enjoyed learning about the world of physics and mathematics, as well as facts about physics and mathematics in the real world. Thank you all for listening and for your time.
Wonderful. Thank you so much. And I'm glad we were able to get you some audio there. It's great. All right. And so with that, I will pass the microphone. Our next project up is the effects of crude oil and dispersant on the mortality and filtration of juvenile oysters. Okay. And do I have our young researcher ready? Is that Mia? All right. Wonderful.
Okay, so in the past few years, there's been increased attention towards oil spills and their effects on aquatic environments. And recently, there's been a lot of demand for oil. So because of this, there's a lot of contamination of environments like rivers, estuaries, and just coastal areas in general because of runoff from land, drilling sites, and of course, the big one, oil spills. Chemicals like dispersant, specifically Crexit 9500, have been used to disperse and help break down remaining oil slicks into droplets. But they've also proved to be kind of harmful to marine life, especially at earlier life stages. There are a few studies on the effects of crude and dispersant on oysters, but so far there have been none on juvenile oysters. Oysters also grow faster and they're more vulnerable and susceptible in earlier life stages. So for this reason and lack of study, I chose to experiment with juvenile oysters. This project looked at if the exposure to crude oil and dispersant would affect the mortality and filtration rates of juvenile oysters. So my results suggested that at the level of exposure, the oysters seemed to tolerate it in terms of mortality. And then not statistically significant, oysters exposed to the crude and dispersant filtered less than those in the control experiment. This could be because of a number of reasons, because of the short duration of my experiment, my low concentrations, and also it's possible because of how short the experiment was that the oysters closed their filtration valves, limiting significance in results.
Wonderful. Thank you so much for sharing. All right, and with that, I will pass the microphone. Our next project is which mask masks most? So do we have our young researcher ready?
Yes, I'm here.
Awesome. Okay, I will stop sharing my screen and pass you the microphone.
Excuse me. Didn't mean to cough in your direction, but this cloth mask with a HEPA filter blocked 98.75% of all my saliva expulsion. If I was wearing this surgical mask, it would have blocked 85%, or this N95 mask would have blocked 62.5% my saliva expulsion. Because these three masks are popular in our current environment, I chose to focus on these three. But I did test 10 different masks, including face shields, neck gaiters, and athletic masks. I did my project which mask masks most because I'm someone who's immunosuppressed. And in our world's current environment, knowing which mask to wear when I leave the house is very important. My basic procedure was to gather materials, cough into the petri dish, and incubate. The algorithm I used to determine the amount of saliva expulsion was P times 0.80, where P equals the percentage of the petri dish that was covered. After getting all the mask efficacy rates, I was able to determine that a cloth mask with a filter was the most effective mask for blocking the saliva expulsion, and an N95 mask was the least effective at blocking saliva expulsion.
Very interesting. Thank you so much for sharing. All right. With that, I am going to pass the mic. Sorry, I wasn't ready. I was totally listening. All right, our next research team. Is it possible to improve the efficiency of solar panels using mirrors? Do we have this team ready?
Yes.
Yep.
Great. All right. Give me just a moment to stop sharing my screen and I will pass you the microphone.
Hello, my name is Diviraju Gangaraju.
And my name is Jackson Boucher.
Our project and research question is it possible to improve the efficiency of solar panels using mirrors?
Before our tests, we did some preliminary research tests, and in these tests, we added more mirrors in hope of improving our efficiency of our solar panels. But after testing, we realized that our idea was not working, so we decided to research the law of reflection, which states that light reflects off at the same angle it hits. And then using this theory, we were able to decide new angles for our mirror.
The test bed consists of an arm with a 25-watt light that would rotate at different angles, which would represent each time of the day. The solar panel was set at a 60-degree angle from the ground, and on the opposite side, the mirror was set at a 135-degree angle.
The angles we set our light at were 120 degrees, 105 degrees, 90 degrees, and 75 degrees. Once we tested, we looked at our results and we noticed that after 105 degrees, the mirror started improving the efficiency of the solar panel. At 75 degrees, the mirror made the biggest differences, and at 120 degrees, the mirror surprisingly decreased the voltage production of the solar panel.
In conclusion, our results supported our hypothesis. This project can be used in the real world by using them on roofs or at solar farms to produce more energy for people. Thank you.
Wonderful. Thank you so much, gentlemen. All right. With that, I will share my screen so that I can pass the microphone. Our next project up is soil health, how land management choices affect erosion risk. And we have a young team of researchers. Are you all ready?
Yes, ma'am.
Yes.
Okay. Give me a second to stop sharing and pass you the microphone. And then you.
Okay, so we did an observational study on soil health and how land management choices affect erosion risk. A term we use in this project is aggregate stability. It's the most common indicator of soil health along with organic carbon. Aggregate stability is the ability of the soil to resist disintegrating when it's put up against natural forces like wind and water erosion. More aggregate stability is good because that means there's less erosion, and erosion has many negative effects on soil health. Our hypothesis is that our land management choices have significant effects on soil health and the amount of aggregate stability. We predict that out of the 3 land managements that we tested, that perennial grass would have the highest aggregate stability. We collected 0 to 5 centimeters of topsoil from 7 different areas around Chatham County, Piedmont. We collected them from forest areas, perennial grass areas, and row crop areas that had to be tilled at least once in the past year. And we used the Slakes app to measure our aggregate stability.
Of the 3 land managements we tested, perennial grass had the highest aggregate stability, followed closely by the forest samples. The row crop samples had a significantly lower aggregate stability than we expected compared to the other 2. After further research, we found this was largely due to living roots and soil cover. While perennial grass and forest samples had living roots and some kind of soil cover year-round, the row crop had less due to crop rotation and tilling. Tilling breaks up the natural soil aggregates, and while this makes it easier for us to garden, you have to consider the negative effects that come along with it. You can counteract some of these effects with cover crops. Soil is a significant part in agriculture, human health management of both land and oceans. That being said, we need to make sure we are taking the best possible care of our soil for our generations and generations to come. Thank you.
Great, thank you so much. All right, with that, I'm going to pass the microphone. Our next project up is Save Me at Sea. So I'm going to look, it's not on my first screen, but do we have our young researcher ready?
Yes.
Yes, wonderful.
My name is
Okay.
Chloe. Oh, sorry.
Nope, you're all right. Just let me stop
Oh.
sharing so they can see you. Wonderful. Go right ahead.
Okay. Hello, my name is Chloe Lee, and this is my project Save Me at Sea. So my project's problem is that people are drowning in currents in the ocean, and my project is a life jacket with a GPS tracker connected to it. And I have 2 wires in the on and off switch, and what happens is I solder them to the on and off switch, and when I place it in the water, it automatically turns on because of the ions of the salt and the chlorine. And wait, I guess that's it.
All right, Chloe, you got another minute if you want to share anything else. You good?
No, I'm good. Thank you. So.
Wonderful. Thank you so much for sharing. All right, I will pass the microphone to our next group. This project is HOBPC hoverboard powered carts. Do we have this team ready?
Yes, my partner has not showed up yet,
Okay.
but I'm ready to go. I can go ahead and present it.
Do you want me to hold off? There's a couple more presentations, then we could ask again if you want.
Yeah. Yes, that's fine. Thank you.
Okay, wonderful. We'll go to the next and we'll come back to you. Okay.
Thank you.
Sure. All right. So surprise, we're going to alien lights. Are you all ready?
Yes, ma'am.
Okay, fantastic. I will stop sharing my screen and pass the microphone to you.
Hi, I'm Kaylee, and this is my partner, Lila. For our science fair project, we did something called alien lights, and we wanted to find out what color of LED light can help the growth of grass, like which one will make it grow tallest. And we measured our data in time series, which is 7 days. And we also had our hypotheses, and my hypothesis was which LED light can make the grass grow the fastest, and I thought it was going to be yellow. Yeah, my hypothesis was that red light would help it grow fastest, but turns out it was actually yellow light. Lila was really smart about this, and she thought about the photosynthesis like of the plant, and it actually ended up working because the yellow light was really good for that. And that's our project.
Wonderful. Thank you so much. All right. With that, I will push us to our next project. And we have, oh, I'm sorry. I forgot to share my screen for you all. The next project up is carbon capture concrete. Will sodium hydroxide as an additive to do-it-yourself concrete bricks lower your carbon footprint? Do we have Sarah ready? Oh,
yep,
I see you. Wonderful. Let me just stop sharing and I will pass the microphone to you.
Thank you. So this is a continuation project of a project I did last year where I sequestered CO2 using a solution of sodium hydroxide or NaOH and water. So this year I wanted to try to do that in a brick that I could use as a building material. So to experiment with my project, I made 3 bricks of different concentrations, a 0% sodium hydroxide brick, a 5%, and a 10%, and I experimented with those. So I found that the bricks reduced the concentration of CO2 in the bag, but the differences between the different concentrations in the bricks was negligible. I also calculated the theoretical maximum CO2 sequestration of both the sodium hydroxide and the cement in each of my bricks. And I found that the 0% NaOH brick absorbed about 30% of the brick's footprint. The 5% brick absorbed about 57% of its footprint, and the 10% brick absorbed about 84% of its footprint. And so I used that information to examine the effect of these bricks on my family's personal carbon footprint. So, and I found that it would take 4,500 0% bricks to offset my family's January 2020 power bill. it would take 2,255% bricks or 1,688 10% bricks. All of my bricks were net negative, whereas they would need to be net positive or over 100% of the bricks footprint offset.
You have
in
30
order for it to
seconds.
be a viable sequestration technique. And if I were to do this project again, which is highly possible because I really like this subject, I would refine my project and explore the use of calcium hydroxide instead of sodium hydroxide.
Wonderful. Thank you so much. All right. We do have a break scheduled next, but before we go to break, I just want to check in with Noah to see if you were able to get ready with your teammate.
We're ready. I'm gonna do it without my teammate.
Okay. All right. Well, then this is the hoverboard powered cart. We're all ready for you.
He's on.
Oh.
Wait, he's joining.
Perfect. So you just
Mom,
tell me
just
when you're
changing
ready.
my name.
All right. Okay. Are you ready? Go. Engineering goal. Our engineering goal was to build a machine to help the lunch ladies at school carry lunches around faster and easier.
Data and analysis. The Hoblet met our engineering goals by being able to drive, that was our main engineering goal, and being able to carry quite a bit of weight. The problems were the seat would not hold the weight of a standing person, and the steering poles were not the appropriate length, and more materials were needed than first thought.
Project design. We came up with the design of the Hublet. We collected the supplies for it. We built the Hublet and tested the Hublet. The Hublet was a hoverboard powered cart that we built out of many different things that was able to go up to 12 miles an hour down our school hallways.
If we could add new designs to it, we would add slots for baskets and lunch trays. And drinks so they don't slide during the operation. And we made this so the lunch ladies, it would be easier for them to deliver lunches faster.
Yes, we did drive it down the hallways.
That's awesome. All right, you have 30 more seconds. Are you all set, or do you need the 30 seconds?
Yeah, I think we're done.
Wonderful.
We could do fun facts.
Oh, go right ahead.
So the price was much less than we thought it would be because we used recycled materials from my dad's work, which is Henson Electric. And the hoverboard is around 1.5 feet long.
All right, wonderful. Well, thank you all so much. What we're going to do now is just pause, take a little break so you all can stand up, get the wiggles out. I know we've been online most of the day. We will be resuming 2 minutes and a mic at 1:05. You do not need to leave the session. So we will be right here. So if you want to step away, you're welcome to just mute your microphone and turn off your camera if that's what you would like, and we will pop back in, and I will remind everybody of the norms and the screen sharing permissions and how we pass the microphone, and then we will keep going with our additional researchers. Thank you all who shared. Thank you so much for sharing. We hope that you will stay and cheer on your peers and learn from their research and ask great questions. And with that, we'll pause and we will jump back in at 1:05. All right, welcome back, folks. Thank you for joining us again after break, and we are going to jump right into 2 minutes with a mic. I am going to go back through the researcher courtesy and what to expect, just so that the folks that were in judging get to have that little piece of orientation. So congratulations, most of you have made it through your judging session today. I hope that you are enjoying the live events. And I will get us started. If you've been on the live events, this session's going to feel a little different. You do have kind of full power to both use your microphone, but also to share your screen. And so in order to help facilitate this, we do just have a couple of researcher courtesy tips that we're going to get started with. If you are in the session, please mute unless it is your current 2 minutes with the microphone. That's why we're calling it 2 minutes with a mic. You're going to be passing the mic along, and I will help facilitate that process. So if you are a parent, welcome. We love that you're on here listening. But if you are not a researcher, we need everyone to stay. If you're not the presenting researcher, we need everyone to stay on mute. We do ask the researchers to respect the timer. With the allowance for folks to share their screen, I can't display a timer because then I would be stealing the screen back. And so what I will do, it might feel a little disruptive, but I will give you a 30-second warning just so that you have an idea of when your 2 minutes are coming to a close. I will do that verbally, and I apologize in advance if it feels disruptive. But I do want you to have the power to share that screen. You should be actively cheering for each other in the chat. Tell people good job, great questions, good research, and ask each other good questions. One of the things as you come out of judging and as you're listening to your peers, asking each other good questions fosters new and great research. And so jump into the chat, cheer each other along, and also jump in there and ask good questions. We won't have time for Q&A as we pass the microphone, but you can certainly take advantage of that in the chat to say, oh, how did you do this? How big was this? What was that? Passing the microphone. If you were in the first session, you're very familiar with this, but it will be done by me. And so what I will do each time is I will start to share my screen again, and the screen will just present the next project title and the researcher or research team that is stepping up to present. So during that time, the team or researcher that just went will mute their microphone and stop sharing their screen. I will share, and it will give the next team a moment to get ready to start sharing. And I will do this verbally back and forth. You all have the power to unmute your mic. If we run into someone, there have been a couple of changes to the judging schedule. If we run into someone who has it's pulled out for a judging session, then we will just move past that slide and give them an opportunity at the end to jump in. Hopefully they will have been able to rejoin us from their judging session. We want folks to get their chance with the microphone. So that was a lot of information. Before I start to pass the microphone, I want to give you the opportunity to ask me any questions. You are welcome to jump on the mic to ask or drop it in the chat, and we can make sure that everyone understands what to expect as we go through this session. All right, wonderful. Well, thank you all for joining us. One of the most important things about research is definitely sharing your research for others to learn from. So we're so excited that you have been able to participate in the state fair, and we are even more excited that you are able to share your research publicly so that we can all ask ourselves the new and next questions for science and engineering. With that, I am going to introduce our first project. The first project is Cellulosic ethanol. Can efficient pretreatment methods increase the ethanol produced? And if I mispronounce something in your project title, feel free to jump in and correct my pronunciation. All right, and so with that, is our first researcher ready?
Yep.
Wonderful. All right, well, I will pass the microphone.
Okay. Hi, everyone. My name is Nihar Gatapana. Oh, I think I'm sharing the wrong screen. Sorry. Can you see my quad chart?
We can.
Okay.
I will reset your timer. Go ahead.
Thank you. So, hi, everyone. My name is Nihar Gatapana. And my project aims at increasing the use of cellulosic ethanol because fossil fuels, as we all know, are very polluting and they are non-renewable. And non-cellulosic ethanol is made from food sources, which leads to more problems like deforestation, increased soil erosion, and reduced food availability. So cellulosic biomass, which is used to make ethanol, is a better option because it is abundantly available on our planet and it is made from resources that are either discarded or not used. And so I experimented with different pretreatment methods to increase the efficiency and the final ethanol output of the cellulosic ethanol production. So I experimented with 3 different biomasses and I put them through 4 different pretreatments. So first was control, which was no pretreatment, then pretreatment 1, which was grinding of biomass, pretreatment 2, which was grinding and boiling of biomass, and pretreatment 3, which is grinding, boiling, and adding citric buffer to my biomass. After, I added enzymes to break down the cellulose into glucose, and I added baker's yeast to ferment my biomass into ethanol, which is what the final product is. So here in my graph, you can see that for all of the biomasses, pretreatment 3, which is grinding, boiling, and adding citric buffer, produced the most ethanol in the end, which was accurate to my hypothesis. And so this shows that the pretreatment method, effective pretreatment methods can increase the efficiency and the amount of ethanol produced in the end, which will reduce the use of fossil fuels, reduce the use of non-cellulosic ethanol, increase the use of cellulosic ethanol, and thereby preventing all of the drawbacks. So this is better for the environment, and this is better for us. Thank you.
Wonderful. Thank you so much. All right, with that, I will pass the microphone. I'll start sharing my screen again so that we can move to our next project. Our next project is homemade water filter. And so do we have our researcher ready to share? Gonna look. Oh, I thought I saw you. I'm gonna give it a minute. Not right now. All right, well, I will move to the next project. I'm gonna make a note so we can revisit this project. Okay. All right, next up, we have rocketology, baking soda plus vinegar equals liftoff. Oh, and I see our young researcher jumping up. Are you ready?
Yeah.
Okay, I will stop sharing and pass you the microphone.
All right. So my name is Rishi Sarvipalli. My project's called Rocketology, Baking Soda plus Vinegar equals Liftoff. My research question is, what is the correct ratio of baking soda to vinegar that will result in the highest launch of my own small-scale rocket, which is a plastic film canister? My hypothesis is that the greater the amount of baking soda, greater will be the amount of carbon dioxide produced, resulting in a greater launch height. My procedure was, first, I took a canister, I put baking soda in the lid of the canister, and then vinegar in the canister itself. Then I snapped the lid on the canister and turned it over, and that's how the chemical reaction occurred. My interpretation of results was that I figured out that the more baking soda there is, the more carbon dioxide is created, resulting in a greater launch height. And my conclusions were, my results were in line with the current literature and research that has already been performed on this. My experiment and results supported my hypothesis that the greater amount of baking soda in the mixture results in a greater launch height. Therefore, my hypothesis was correct. I was able to achieve the greatest launch height when I mixed 1 teaspoon of baking soda to 3 teaspoons of vinegar. Additionally, my results also reflected Newton's third law of motion. For every action, there's an equal and opposite reaction. The chemical reaction generated carbon dioxide gas that exerted pressure or force against the inside of the canister, which was the action, and resulted in an upwards thrust of the canister, which was the reaction. Thank you.
Wonderful. Thank you so much. I will help to pass the microphone. And so next up, we have drip, 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 splish, splash. Do we have our researcher ready? I know I saw this name. Yes, wonderful. All right, I will stop sharing. And you can have the mic.
Well, hello everyone. My name is Sanu Sriram, and my project is comparing an Arduino-based automatic drip irrigation system to an Arduino-based automatic localized irrigation system. And this works by using this, which is a soil moisture sensor. So what it does, it detects the soil moisture levels. So I just keep it in my pot, and then if the soil moisture sensor detects that the soil is dry, water will automatically be supplied to the plant until it receives proper and consistent hydration. And this works for both methods, which are drip and localized. So localized irrigation is water distributed under low pressure through pipe networks applied to each plant. And drip irrigation is water distributed under low pressure. It's a type of localized irrigation in which water is distributed drop by drop near the plant's root. And after my 5-week experimental period, I was able to see that the plant water using drip irrigation grew by 5 inches, and the plant water using localized irrigation grew by 3 inches. And I made this irrigation system to help people in their gardening endeavors. If they're out of town, not aware of proper irrigating techniques, or if they're just forgetful like me. And this system can be expanded to be used on a larger scale or outdoors. And I plan on making the system more effective than it already is by adding temperature and humidity as factors in determining when and how much water to supply to the plant.
30 seconds.
And another thing about me is I actually have a vegetable garden in the back of my house, and it takes me 30 minutes of continuous hydration to water all of the plants. And now that's just for one garden. So then I started to wonder how much water was used by North Carolina just in agriculture. And then I started to think on larger scales like the United States and the world. And yeah, I just think that we can all do our part in saving water by watering our plants consistently with proper hydration without much water wastage.
Great. Thank you so much. Wonderful. All right, I will pass the microphone. Our next project is gray water to green water. Irrigate a landscape using a washing machine. Do we have our researcher ready?
Yes, you do.
Okay, I'll stop sharing the screen and I will pass you the microphone.
Okay. It might take me a minute to open up the...
Okay, when you share your screen, you just tell me when you're ready and I'll start your timer.
Okay. It's opening. Can you see my screen?
Coming up, I'll let you know when it pops up. Yes, we can see your quad chart. Is that what you want us to see?
Yeah.
Perfect. All right. You're ready to go.
Hello, my name is Adarsh Lakshman. My project is called Gray Water to Green Water, Irrigate a Landscape Using a Washing Machine. When I went to a water treatment plant, I learned that they filtered large amounts of water and that water was called gray water. That is what inspired me for this project. I also learned that they diverted this water and reused it. I thought about doing the same thing, but for my own home and for my own washing machine. In my project, I created a diversion and filtration mechanism in order to divert and filter gray water from my washing machine. My filter had sand, large gravel, small gravel, and sponge. I used those materials because they help filter water each of those filter materials helped filter water in a different way. Sand helped filter chemicals, and gravel helped filter water in a process called oxygenation, and sponge helped keep the sand where it is. I learned that as the washing machine ran, the TDS also got lower. And that means that as the washing machine runs, the dirt goes away on your shirts and other things in the washing machine, which means the TDS gets lower. Making a gray water system is very important, and also saving water is very important because there is a major water crisis going on in the world right now, and people have to try and help in any way they can, which means by saving water. That is what my gray water system does. I also learned that the lowest TDS I got was 98, which is very close to the amount of total dissolved solids in tap water, which means that filtered gray water is close to the water that you drink every single day. Thank you.
Wonderful. Thank you so much. Okay, I will grab the screen and share our next project. So our next project is how fast can a soccer ball roll for a distance of 10 yards? And is our young researcher ready? Do we have Aiden on? All All right, we will move to the next project and I'll make a note that to check on that project in a little bit. So our next project is how roads affect local water bodies. Do we have a Nushri? All right. Oh, we have a Rishi joining. Okay, I'll make a note. So the next project, questioning the queue. I'm pretty sure I saw Maya on here. Do we have Maya ready?
Yes, I'm about to share my screen.
Okay, I'll stop sharing and I'll pass you the mic. You tell me when you're ready.
Can you see my quad chart?
We can.
Okay. Hi, I'm Maya Roseborough, and I am excited to present my mathematical project titled Questioning the Queue. I analyzed the attraction wait times of theme parks in a large amusement park. I began this project because I needed to satisfy my curiosity. My question was, what is the effect of length of time after park opening on the wait times of attractions? My hypothesis was there's a correlation between the time of day and the wait times of attractions of each of the theme parks. I believe that during the initial park opening, the average queuing wait time of an attraction would be shorter, and the wait time for such an attraction would peak during the afternoon and the evening. I collected data for each day for 7 days for each of the 4 theme parks. As you can see, each of the graphs has a similar curve, with the exception of Innovation Park, the park in blue, and all the curves resemble a parabola. From my data, I was able to formulate a prediction model to predict the average wait time within a certain hour after the park opens of an attraction. My prediction model had 3 tiers, each with varying ranges of time. With the exception of Innovation Park, I concluded that my hypothesis was true. Once my project was complete, I had a few questions for further research. Is the rate of arrival for my queues exponential with a limit, constant with a limit, or would it be easier to model if I assumed all the customers arrived in the queue at the same time? I asked myself if this tourist destination even used queuing theory, and if calculated, would there be a difference between the theoretical average wait time of the queue and the average wait time predicted using their ride capacity?
At 30 seconds.
I am excited to say that this project brought a lot more questions than answers. Queuing impacts every facet of our lives. Queuing theory applies to hospitals, optimizing treatment efficiency and quality. Queuing impacts shopping, improving customer service and stock of products. Queuing impacts transportation, increasing productivity and reducing environmental influence through conservation. I believe that more studies should be conducted to analyze queuing systems, especially as we move into this new frontier of virtual queuing.
Wonderful, thank you so much. Okay, I will pass the microphone. Our next project up is called Baking Bread. And so do we have our researcher on?
Yes, I'm here.
Great, okay, I'll stop sharing and I will pass you the microphone.
Hi, I'm Ellie Heggie, and in my project, I figured out how much time you need to wait for your bread to rise to get it to a good height. My hypothesis was the longer you wait for your bread dough to rise, the higher your bread will be. I made the bread dough according to the recipe. After making the bread dough, I let that rise for 1 hour, and then I separated it into 3 equal parts, measuring once after its first rise, once after being proofed, and once after fully baking. And I repeated that process with the 2 other bread doughs. My variable is the amount of time that I let my bread dough rise. My dependent variable is the height of my bread at the end. My independent variable is the wait time. My constants are the recipe and ingredients. In my conclusions, I found that my result did not fully support my hypothesis, which said the longer you wait for your bread to rise, the higher your bread will be. After baking, they all ended at 5.08 centimeters, and my application is it doesn't matter how long you wait for your bread to rise.
commercial bakers can also use this information to know it doesn't matter the time you wait.
Great, thank you so much. All right, with that, we will pass the microphone. Our next project up is called Experiment 4.0, From Turbid to Clear. And so do we have our young researcher on the line?
Yes, I'm here.
Great, all right, I'm gonna stop sharing and I'll pass the microphone to you.
All right. Can you see my screen?
Yep, we can see your quad chart.
All right. Hello and good afternoon. My name is Manar, and today I'm going to be talking about my project, which is called Experiment 4.0, From Turbid to Clear. So many people are out there drinking water that is contaminated, and this adds a number of health problems to them. And careful management of this essential global resource is a key feature to a sustainable future. However, at the current time, there's a continuous deterioration of coastal waters owing to pollution, and ocean acidification is having an adversarial effect on the functioning of ecosystems and biodiversity. Helping life below the water to thrive and people to have clean and purified water is one of my goals, and people with less health problems all over the world. So in the project, I'm conducting a turbidity meter and an efflumeter involving a chemical coagulation process, and I wish to find the most effective water decontamination method. So assembling a circuit on a breadboard, making electronic sensors, setting up a multimeter and having a photoresistor for measurements, making a series of dilutions, having a known concentration, and adding a chemical coagulant, which is alum, to my cuvettes were all a part of my project design. Overall, the method succeeded and did well, and turbidity escalated with less time and reduced twice with more time. For the TSS, or the total spitted solid, it increased twice with less time and decreased twice with more time using flocculation and coagulation. And the overall amount was in milligrams of microliters. So the more stirring and the more utilized mixing, the better results I had gotten. Allow me to explain a little bit more further. Therefore, this involves mixing attenuated water in the cuvette right before measuring the resistance and data for better results. Agitation and speed influence also played an important role during my data. The agitation, speed influence, and stirring best resulted in the 15 minutes, proving the point of the supplementary time, the better. There will last
30 seconds.
Turbidity and TSS. To answer my research question, which was what properties of particles determine how they contribute to the turbidity of water. So I figured it out through my procedure. The turbidity of water is based on the amount of light scattered by particles in the water column. Therefore, the more particles that are present, the more light that will be scattered. And as such, turbidity and total spent solids are related. Thank you so much for your time.
Wonderful, thank you so much. Okay, I'm going to pass the microphone to our next project, and our next project up is Bubble Bubble, No More Trouble. I'm sure. Do we have our researcher?
Right here.
Great. Okay. I will stop sharing my screen and I'll pass the microphone to you.
Okay, I don't know if this is gonna work because it doesn't. So can you see my screen?
Yep, we can see it. It worked.
So this is my project Bubble Bubble No More Trouble. I'm really interested in paleontology, and I was doing some research and found that the human-made noises cause a lot of harm to whales and dolphins. So I wanted to figure out what could be done to prevent this noise. I came across the bubble curtain, which is like a ring of pipe or hose around a source of noise, such as pile driving or underwater construction, and releases bubbles through closely spaced holes. This technique is really efficient, however, it is not perfect, and some noise still escapes the curtain. So I decided to do my experiment and find which size of air bubble best reduces noise. To do this, I made an underwater speaker out of PVC pipe, an electromagnetic speaker coil, and a thin sheet of metal, a bubble curtain, which was made out of PVC pipe, and I used a hydrophone, which is a microphone designed to work underwater. I used 3 different air pressures over a variety of 8 sound frequencies. I also tested each sound frequency with no bubbles as a control group. This was used to calculate how much sound was reduced by the bubble curtain. I found that the higher the frequency was, the more efficient the bubble curtain was. This is because the wavelength of the sound better matches the size of the bubbles when it's a higher frequency. The higher pressures also reduced sound better because when it's a higher pressure,
30 seconds.
The bubbles are more frequent, so there's less gaps in the curtain. The bubbles produced at higher pressures are also bigger, meaning that they have
there's less air pressure inside each individual bubble, and so there's a lower density. So sound would travel slower through bigger bubbles than it would through smaller bubbles. And I guess that's it. Thank you.
Great, thank you so much. All right, our next project up is the excellent toothpaste experiment. So do we have, oh yep, I see it. I see you. Wonderful. All right, I'll stop sharing and you tell me when you're ready.
Hi, my name is Maeve Heaney and I'm a 6th grader at St. Mark Catholic School in Wellington, North Carolina. My project is called the Excellent Toothpaste Experiment. I've always brushed my teeth with fluoride toothpaste because I've always been told it's most effective at preventing tooth decay. So I wanted to prove this and show that it is true. So what I did in my experiment is I soaked 3 eggs in soda, juice, and chocolate milk for 3 days. I chose these liquids because they are sugary and will damage the eggshells. I chose eggs to represent teeth because they have similar composition to tooth enamel. Next, I took another 3 eggs and coated them in fluoride toothpaste and soaked them in the liquids. Then I took 3 more eggs and coated them in non-fluoride toothpaste and soaked them in the liquids. After the 3 days, I compared the eggs in their 3 categories, described the damage to the eggs, and I made a data table and graph to make my results more visible and more understanding. My results showed that the fluoride toothpaste was most effective at preventing tooth decay because the eggs coated in it showed the least damage. The non-fluoride toothpaste provided some protection, but not as much as the fluoride toothpaste.
Wonderful, thank you so much. All right, I will pass the mic to our next project. Our next project is called Weather Check, an indoor weather station. Do we have our team on? Great. All right, I'll pass the microphone.
My name is DT Teklapati. I'm in 7th grade from Jane Freeze Magna Middle School.
My name is Akshas Reddy. I'm in 6th grade at Jane Freeze Magna Middle School.
And our project is called Weather Check. So as part of our science fair project, we built an indoor weather station that can measure temperature, humidity, and air pressure.
Our goal of this project is to consistently get accurate results using low-cost materials.
And we chose this project in an effort to bring a low-cost and accurate indoor weather sensor that can be used in every house.
When it comes to materials, we use low-cost items such as the Raspberry Pi and environment sensor. And during testing, we made sure our device was accurate by testing over a 4-day course at the same location.
This device can be used in a numerous number of places. For example, you can use it at a museum where certain artifacts need to be kept at certain temperature, humidity, and air pressure levels. Another generic area to use it is when you need to keep your plants inside for the winter. You can use this device to keep track of the levels in that room.
Our results came back with less than 1 of each unit for all 4 days. So as far as our testing goes, we were pretty accurate.
So in conclusion, our results prove that we can develop a low-cost indoor weather station using the Raspberry Pi, the BMU 280 sensor, and Python.
Great, thank you so much. Okay, our next project is light versus dark. How does the amount of light affect seed germination? Do we have our researcher ready? Looking for Aiden. I do not see Aiden. All right, I will move that in the queue. Maybe Aiden will be able to join us. Okay, the next project is testing Pavlov's theory with betas. Do you have Natalia?
Yep.
Okay, wonderful. I'll stop sharing and I will pass it to you.
Hi, my name is Natalia Mewborn. I'm in 8th grade at St. Mark Catholic School. My project was testing Pavlov's theory with betas. My research question was, can beta fish be trained to associate the sound of a bell with feeding time? Do
respond differently than females. For my process, I had 4 beta fish, 2 males and 2 females. I had 4 separate fish bowls with conditioned water. I rang a bell for 30 seconds to one of the males and females. Then I fed them and wrote down their behavior. These were the experiment. For the other 2, I fed them without ringing the bell, and I recorded their behavior. I repeated this process for 4 weeks. The last week, I removed the bell with the test fish. My research demonstrated that the betas could learn to respond to a stimulus in a similar way to Pavlov's dogs. After a few days, the experiment betas realized that the bell meant food. The beta's enthusiasm increased after the first week and remained till the end. The males responded slightly faster than the females. My research question was proven correct. Thank you.
Wonderful, thanks so much. All right, so I'm going to share my screen again. I'm just gonna double check on these couple of projects that maybe got pulled into judging times. Do we have our researcher, Naylan, on here for homemade water filters? All right, I think I saw Anushri join us. How roads affect local water bodies?
Yeah, I'm here.
Wonderful. Okay, great. So I will stop sharing and pass you the microphone. Thank you for joining us.
Yeah. Can you guys see this?
It's still loading. I'll tell you when it pops up. Nope, it's stopped. Do you want to try again? That worked. Wonderful. All right, you tell me when you're ready and I'll hit start. And I think you muted yourself by accident.
Sorry about that.
No, perfect.
So my name is Anushri Seshadri, and my project is titled How Roads Affect Local Water Bodies. To execute this project, I tested 4 factors in local and nearby creeks: ammonia, nitrate, nitrite, and pH levels. I investigated these factors in 3 streams directly on the side of a road, and 3 streams in the middle of a forest and uphill from a road. I hypothesized that my pH levels next to the roads would be slightly acidic, and my ammonia, nitrite, and nitrate levels would be higher due to the chemical runoff from nearby roads and farms. The latter statement was proven correct, as my ammonia, nitrate, and nitrite levels ranged from 0.2 to 3.5 parts per million higher than the forest creek's counterparts, and most of the forest creeks ranged from 0 to 0.025 parts per million, so on the very low side. However, my pH levels varied, and I marked them as inconclusive as they didn't follow a specific pattern. According to my background research, the higher ammonia and nitrite levels are a product of poorly decomposed organic material, because organic material has to break down into smaller and safer compounds before it actually benefits the environment with its fertilizing properties. A study done by a university in Germany found that benzene, a common chemical in gasoline, actually inhibits decomposition. So I inferred that benzene from the gasoline running off into roads would be the cause of my higher ammonia and nitrite levels. And for the higher nitrate levels, there's already a very prevalent problem in the world today, which is yard and farm fertilizer runoff. And
30 seconds.
Fertilizers are rich in nitrates, and this caused the nitrate levels to go up. All of these factors in excess have bad effects on the water, as they contribute to oxygen depletion and bad diseases in aquatic organisms. What brings all these together are roads, as they are excellent channels, and through their outlet ditches that people have carved into them, they run off directly into creeks nearby. In the future, I would like to investigate the most effective barrier methods into preventing this harmful problem to our environment.
Thank you so much for sharing. All right, we have 2 more projects to just double check on before we close for the day. Did we have Aiden join us? How fast can a soccer ball roll for a distance of 10 yards? All right, and one more to check on is, oh, I think I'm seeing this researcher join us right now. Hang on one second. I see connecting to audio. Let's just give it a second. I can see him jumping in. All right, I think that's you, Aiden. Is that you? Light versus dark. How does the amount of light affect seed germination?
Yes.
Great. All right, I'll stop sharing. Welcome. And you tell me when you're ready and I'll start the 2 minutes.
Should I change my name?
It's okay. Well, you can take a moment to do that now if you want.
All right.
That worked. Are you ready?
Yep.
All right, excellent. Go right ahead.
Is there a link or something? Or
Yep, this is just your 2-minute research summary. Yeah.
Oh. My project was about how a light affects seed germination. When I started this, I got 4 seed trays and labeled one of them 24-hour light, another one 16-hour light, 8-hour light, and 24-hour darkness. I put 2 seeds per cell in the trays and covered them lightly with dirt. I then put the 8-hour light in a closet that is back there somewhere. And I put 24-hour light in a grow lamp. I put the 8-hour light and 16-hour light in an alternate thing where they'll just go in the closet and also in the glow lamp. I thought for my hypothesis that the 16-hour light will do the best because it would observe and get the most light of a normal day for a normal seed. But I was wrong because 24-hour light was the best. Out of all the seed germination, it got a 100% seed rate, and 16 hours got 92. 8 hours got 75, and also 0 hours got 75.
It's excellent timing, Aiden. You got it right in. You're our last presenter for our 2 minutes with a mic, so thank you. With that, I am going to jump back in to my screen sharing and tell you, I'll move us forward. Everyone did an amazing job, so thank you so much for joining us and for being willing to share your research. It's so important that you do that as we all navigate our paths together. We have to share our research and share our stories so that everyone can understand there are so many different pathways through the world and we can all continue our research and follow our passions. And so we want to pause here and congratulate you. You are now North Carolina Science and Engineering Fair alumni. Hooray, excellent job. We do know if you've seen our speakers, our Spark speakers, they are also alumni and we love to capture stories. And so if you are interested, oops, I apologize. If you are interested in doing an alumni interview to be featured on our website, I would be happy to connect with you. You just shoot me an email and we can set that up for sometime in May. We love to hear the stories of all of our researchers and we would love to spotlight you on our website. So don't forget, wear it proudly, you are an alumni. Don't forget that you can also join us next weekend for any live events that we do host. We do have the same series of events where we will have 3 alumni Spark speakers to start inspiring you in the morning and ask good questions. And you can jump into those through Symposium. And then we do have our distinguished lunch speakers, which is the STEM and learning team from Marbles Museum, who will talk to us about the secret ingredients of science. So that's at 11:30 for our lunch hour next week. And then most importantly, don't forget to join us tomorrow for your division's award ceremony. The Junior Division Awards will be done live on Zoom, and we look forward to seeing you at that. All of our live events have been recorded, and so you will get a link to all of the recordings. I sent one out after the last one that has all of the senior divisions. I will add to it all of the junior division recordings from today, and we hope that you will point to your 2 minutes with a mic session proudly and share it with teachers, aunts and uncles, grandparents, everybody who is also going to be proud of how well you did your research and you shared your research. If you want to follow us on any of our social media sites, we are always looking to communicate, share out, and invite you to other events. And so I just dropped into the chat our Twitter, the link for our Twitter handle, our Instagram, and our Facebook page. We hope that you will follow us, and we will also put out the playlist link via social media so you can grab it there. With that, we are done with our junior division competition. Thank you so much for joining us and for sharing your research and for doing your research. Your work is important and will move us forward. You are amazing representatives of North Carolina.